It says the polar function r equals f of theta. R equals f of theta. So it's a little bit backwards from what you've known. What we have done always is f of x equals whatever, right? So this is r equals f of theta. Consists of ordered pairs r comma theta, where the input values are angle measures theta and the outputs are the radii r. Okay. Use a calculator to approximate the r of theta values in each example. Round r values to the table or in the table to 1 decimal place. And then we're going to plot these points. So our first function here, r of theta equals 4 cosine of theta. So these values of theta, the angle measures, are the inputs. And the outputs are going to be r of theta. Are y'all following this? So it doesn't seem so bad, right? What's cosine of 0? Oh, man. On second thought, we pause and we do this lesson tomorrow.
1.
Cosine of 0 is 1.
Yes.
So 4 times 1? 4. Okay. Cosine of pi over 6.
No. The square root of 3 over 2.
Square root 3 over 2 times 4. So you would have 2 square root 3.
Yeah.
Right? That's going to come out to 3.5. If you put that in your calculator, you would round that to 1 decimal place. I think it's 3.46. Is that right?
Yes.
Okay, so we're going 3.5 on that deal. Cosine of pi over 3? Half. 4 times a half?
2.
Okay. Cosine of pi over 2?
0.
0. Definitely 0. Cosine of 2 pi over 3? That's a negative short.
Wait, hold on. 2 pi over 3. It would be negative 1/2.
Okay, 4 times negative half?
Negative 2.
Okay. A negative long, we're going to have negative 3.5. And at pi, cosine of pi is?
Negative 1.
So we're going to have negative 4. Okay, so we plot these by going to the angle and then the r of theta value. So at 0, we're going to be at 4. So measure angle 0, go out 4 radii away. Is that making sense? Pi over 6, we're going up to 3.5. So that's going to be between radius of 3 and radius of 4. Pi over 3, comma 2. Pi over 3, comma 2. Pi over 2, comma 0. Pi over 2 is going to be your vertical y-axis, the positive one. Right? 2 pi over 3, so that's going to be this angle measure, but we're at negative 2. So we're going to flip across the origin, right? So we're going 180 degrees away from that. We're going 2 away from 0 in the opposite direction. Got a bunch of stuff on my graph that I don't need. 5 pi over 6 is going to be here, but we're at negative 3.5. So we'll go 1, 2, 3, 4, negative 3.5. Does yours kind of look like mine? And then at pi, we're supposed to be at negative 4. So we'll go out. That's going to share the same point as 0, 4. So we're going to start here. Start at your 0, 4 ordered pair. And you go in a clockwise direction to connect your dots. So like this. Ooh. Makes a circle. Counterclockwise. Counterclockwise. Move counterclockwise throughout the points. That's your hint. Counterclockwise. Why does it matter? Because sometimes it's not a circle where it would matter that I went this way or this way. Okay, so here is the graph of the rectangular function in the xy plane. This is the rectangular picture of what we just drew. This is 4 cosine theta. On the interval from 0 to pi over 2, what sign do the outputs have? From 0 to pi over 2, what are your outputs? Where are they located? Positive. They're above the x-axis. So on the interval from 0 to pi over 2, these are positive. How about from pi over 2 to 2 pi? They're negative. Well, how does that relate to the polar curve that you just graphed up here? From 0 to pi over 2. So let's mark that. That's going to be from here to here. What do you tell? They're positive. And from pi over 2 to 2 pi, where are they located? Negative. Can you tell? Okay, we can relate that pretty well. Use the polar graphing application on your calculator to check your polar graph. Make sure that your calculator is in radian mode. The default domain restriction on most calculators is 0 to 2 pi. So that means it's not just going to continue to circle. It understands to stop once it's done one full revolution. Okay, so pause on the video and let's turn the page. It says complete the table and sketch the graph. So here we have example 2. I want you to put this function in your calculator. Okay, this 2 minus 4 cosine theta, because we kind of bombed on trying to come up with these numbers a while ago. So put these in your grapher. And let's go to our table. Make sure your table is set to independent, what? Ask. So put on your table independent set to ask so that we can input these radians and output a y value. So you're going to put the function in your grapher. That function up there, 2 minus 4 cosine theta. And you're going to come up with a table. And you're setting your table settings to independent ask.
Does the graph have to be older?
Looks like Pac-Man.
The table. We're putting in these radian measures. So try 0. What do you output if you put in 0? Negative 2.
How do you make a table?
Yeah, it does have to be. It has to be the same as last time.
Okay.
Table.
Independent set to ask. If x is 0, so your table settings, if x is 0, our output's negative 2. Are y'all rolling with me?
Independent is ask.
Independent set to ask. How about if x is pi over 6? Anybody got a number there? Negative 1.5. Let's round to 1 decimal here.
Wait, so pi over 6, let's try that too. Pi. I didn't hear.
Everybody got their table to ask? You go to edit table settings.
Okay, I got 2.
You got 2 for pi over 2?
Yeah.
Good. And for 2 pi over 3? 4. And for 5 pi over 6? And for pi? We could have just done 2 minus the values we had on the last table. But I don't know. I just thought maybe this would be good for us. Indeed, I was wrong. Okay, so at 0, we're at negative 2. We want to plot this value out here. At pi over 6, we're at negative 1.5. So that's going to be here. Pi over 3, comma 0. So that's actually on the origin. Pi over 2, comma 2. 2 pi over 3, which is going to be this guy right here. He's 2 pi over 3, comma 4. So 1, 2, 3, 4. 5 pi over 6, comma 5.5. So 4, 5.5. And pi, comma 6. It makes me think of like a seashell. Like a, again, we start and then we go in the counterclockwise direction.
That is what it would look like, Frankie.
I'm glad you knew things, Frankie.
Cool?
Wait, you put pi over there? Wait. Oh no. Oh, whoa.
Okay, we're going to pause.
Oh, wait.
Okay, so here's the graph of that particular function in the rectangular plane. What do you know about symmetry, and how could we finish this function to 2 pi?
Continue the spiral.
Continue the spiral?
No, because it makes it easy.
Continue the smile.
It's reflected, right? So the second half of this particular function is going to go back around through here, and it's going to finish back where it started. Maybe yours is a little bit more symmetric than mine.
Oh, no.
No, if we had time, we could be very exact.
No.
Okay, so the question here says, what sign do the outputs have on 0 to pi over 3 and 5 pi over 3 to 2 pi? What sign do our outputs have in those two regions?
Like one?
We're talking about these. They're both negative. On 0 to pi over 3 and from 5 pi over 3 to 2 pi. Check it right here. They're negative. Can you tell?
Yeah.
So how do those relate to the polar curve? Well, they're the inside ones. They're the ones that come up in the inner loop. The solution here said they form the inner loop.
Does it go inside the circle?
Yeah, they go inside the circle. We okay here? Hello. Are we good?
Yes.
Okay. So some classic polar curves. It says some polar curves have special names, which are given in the examples below. The AP exam does not reference these names, so don't freak out if you can't pronounce them or remember them. It's okay. The graph of r theta equals 4 cosine theta is example 1 is the graph of a circle. The following polar function forms produce circles. So if you see r of theta equals a, or r of theta equals a sine theta, or r of a equals a cosine theta. Now I want to compare, well, you're going to do this activity in just a second. It says experiment with your calculator using both positive and negative values of a, as well as both sine and cosine to graph some various circles. Below are a few examples for you to try. So get your calculator, and you're going to try to draw these circles from looking at the pictures on your calculator.
What?
Yeah. So really quickly, put in 4 sine theta, and then push enter, and talk to me about this particular circle.
0, 0.
4 sine.
Okay, goes through 0, 0. What else?
I'm still putting in my calculator.
Goes up to 4. Why? Because sine of pi over 2 is 1. So at pi over 2, we're at radius 4, right? So what I noticed about this was this had a radius of 4, right? 4 away from the origin. And this circle was mapped vertically. Would you agree with that? Okay. What do you expect about this next one, negative 3 cosine theta? Right, that's what we expect. We expect that it's going to come out and have a diameter of 3 if you're talking to Nikki.
I mean, I thought it was going to be 0. It was cosine 0, 0,
Right, so at 0, it's 0. But if you go all the way around, right, cosine of negative pi is, or cosine of pi would be negative 1. So that's why we're out here at 3,
Why did we go to pi? Did we just pick pi?
where we're on 0 to 2 pi.
Oh, okay.
Pi's in there. What do you expect on the bottom one, or the next one? It's going to be down. Yeah,
Diameter of 2.
it's a little circle. And so what happens if I throw off the sine or the cosine? What if I just have r of theta equals 5? What do you expect? Is it? Try it. R of theta equals 5.
It's a bigger circle.
It's a bigger circle. And where is it located?
So it goes, then it goes out 5.
Its origin is the center, isn't that right? It's not up or sideways. It's centered. That's because sine would take it up or down, and cosine would take it left or right. But if you don't have either one of those trig functions, then we're just talking about a circle centered on the origin.
Ooh, what about tangent?
Cool. Okay, let's look at the next page. This is the last piece of information. So this one says the graph of r of theta. I turned them loose on a calculator and they can't help themselves. Okay. The graph of r of theta equals 2 minus 4 cosine theta on 0 to 2 pi in example 2 is the graph of a polar function called a limicon. When the absolute value of A equals the absolute value of B, the graph is called a cardioid. Cardioid. Everybody hear that word, cardioid. What do you think these make?
I do not do cardio.
What do you think the shape is? It's a heart. It makes a heart-shaped graph.
Oh.
Yeah, it's pretty cool.
It's a treadmill.
Right, exactly, because we hear cardio and we think of heart. That's why they called this. So the following function produced limicons a plus b sine theta and a plus b cosine theta. Experiment with your calculator using both positive and negative values. So I want you to put these functions in your calculator and see what happens. See if you can kind of draw them. They're really cool.
Okay, good question. This is what tangent looks like, right?
Okay, do these ones.
You can't even, but
Yeah, I don't know. Don't try that. So some of these actually look a lot like hearts. They're kind of cute. So next time you're trying a Valentine's card, you can totally make a trig function and send it. You're welcome. You're welcome for that wonderful relationship advice.
That's what we're going to think about.
The second kind have loops. Can you see the loop here?
The limicons, the kidney beans.
And then the third ones, it say they're dimpled like a kidney bean. So you're not actually seeing the point, but you are seeing that it kind of comes in less like a circle. Cool?
yeah.
Yeah. Have you enjoyed this?
Yeah.
Cool.
It's a whole lot easier than the other methods.
All right, class, here we go. Hey, these are about to be super awesome. Use your calculator to graph 4 sine of 2 theta. Okay, so now we're putting in a little bit of a period change. Oh.
Oh, it like makes multiple question mark? You didn't say that.
Did you do it?
Yeah.
4 sine of 2 theta. It's a flower. 4 sine of 2 theta. And so this is called a rose. The following polar function forms produce roses. R of theta equals a sine of b theta. R of theta equals a cosine of b theta. Notice the difference. Okay, when we had plus or minus and the period didn't change, those were the cardioids. When we have an amplitude and a period, now we see the flower petals, the rose. Okay, check out the bottom, the rule down here. When b is odd, the domain is 0 to pi, and the number of petals is b. If b is even, domain is 0 to 2 pi, and the number of petals is 2b. So how many petals do you expect to have on this cosine one? Cosine of 2 theta. 4 petals. Because the b is even, it's 2, and your number of petals is 2 times b. So that would give you 4 petals. And each petal is going to be a distance of 4 away from the origin. So if I'm going to plot this real quickly, you can graph it on your calculator. That's what I did to look at it. Plotting so hard on this thing. 1, 2, 3, 4. Okay, so mine's going to look like...
What does tangent do?
I don't know.
We're about to find out.
It's all the parts that aren't graphed on the XY plane. So like it fills in your asymptotes. It looks really weird.
How many petals do you think on the second one? 2 sine 3 theta. 3. And each one is going to be radius 2. Each petal. So this is a little flower. Little.
And the next one has a couple,
How many?
like
8. 8 petals of radius 4. Do y'all think this is awesome or no? Am I the only person that... Like, I was doing this during your test this morning, and I thought it was awesome. And I really wanted to tell people what I was doing, but nobody in my room would have thought it was cool.
Which room were you
I just want to know, like...
Because I visited this room like 4 different times.
I was in a different room.
I know, I was very sad. I was supposed to say hi in bed, nothing that hard.
Oh.
Whoa. It's like the star of Jesus.
Tell me that's not cool. It is cool. It is. It is. Okay, so that wraps up this lesson. We'll do 3:15 tomorrow, and then we'll have time to work on the homework assignments. Okay? We have only one lesson left.
Okay. Let's get
I stayed awake all day today.